All right, everybody, welcome in to lecture 15 for week 15. Actually, 14. Sorry, 15 is next week. But yeah, just this lecture, one more, and you're done. You are right at the end. Super proud of you. I will not waste your time. Let's hop right into it. As you can see, which I love to see, a lot of people are getting their discussion boards in, which is great. Perfect. All you got to do is complete it. You don't have to worry about, this many number of words or hidden certain key terms. Just answer it in your own words to the best of your ability. You get the points. That's it. Same with CK12, which I will talk about. Obviously I'll talk about a little bit here. But remember, it's completeness, not getting 100%. That will get you that A. Now, granted, if it's complete and everything is 100%, yeah, you're going to get the A. But all I want you to do is just complete these units, and you'll still get your good grade. Okay, so I'm sorry. Okay, it was just something on my watch. Let's hop into it. I'm sorry. Here we go. Okay, so if we go into our course page here, you'll see all the familiar friends. If you still do not know how to contact me, well, time's almost too late. But you still can. Even if you leave the class, you can always still contact me. The last night, I'll hand out my contact info, so you can always, reach out if you ever need anything. So right here, unless you need anything fixed, I'm not like a handyman. Like the most I've ever done, that's like my biggest achievement with handyman or handy person stuff is I changed my brakes once, and I felt like a god after that. And but anything else, anything breaks down on my car and it's not out of gas, I don't know how to fix it. So you don't need to know that. But anyway, so all the familiar stuff all the way down here. I don't have a new grade sheet up. I will get one up as soon as I can. It'll either be before class tomorrow night or first thing Friday before noon. So let's hop into our module. You'll see it right here, ready to go for you. This is next week, but so this week we're just looking at our winds. We want to talk about wind, and I really like talking about wind. I think it's a neat thing. It's one of the phenomena that we experience all the time. Like you, maybe not all the time, but you step outside, typically there's some sort of breeze. And living here in Southern California, we're all very familiar with the Santa Ana wind gusts. And so we experience this on a daily basis, but we don't really think well, where does it come from? Why is this happening? And so that's why I really like this unit, and it's really, really cool. So the discussion board on this one has to do with the Coriolis effect. Now, we will be talking a little bit about the Coriolis effect. It comes into play much more next week. Hint, hint for your discussion board. I tell you to draw on this week's knowledge, and it'll be right here. So anyway, the Coriolis effect is really, really like a powerful thing. It sort of determines the direction of flow for different fluids in different hemispheres. So we have to start thinking about air as a fluid, because it's just a fluid is anything that can have motion. Of course, air can have motion, water can have motion, lava can have motion. So those are all considered fluids. But anyway, so all I want you to do, because the Coriolis effect, man, we can get really scientific with it. We can talk about why it spins in certain directions in different hemispheres, how the speeds are different at the poles as opposed to the equator, and therefore, the drag that gets put on air masses that are moving towards the equator or away from the equator either speed up or slow down, and that's what creates the direction that they spin. We're not getting into all that. Trust me, that is a headache and a half, and I'm not going to do that to you in the last 2 weeks class. So all I want you to do is just watch this, soak it in, and then in your own words, simply put, however you would like to, what is the Coriolis effect, and how does it affect the movement of air? So just the Coriolis effect is this. It affects the movement of air by doing this. It doesn't have to be super detailed. It doesn't have to be super long. Just quick and dirty and to the point, and we're all good to go. And that is your one question for the discussion board. Not too bad. I'm not going to make things harder for you in these last few weeks. Trust me. Okay, hopping on back. All the familiar friends that we're used to seeing. Discussion board. Oh, wait, that's not active yet. Now it is. There you go. So discussion board's there, ready to go for you. The PowerPoint. Ooh, that was the Hurricanes one. Bad me. Jeez. I think 14 weeks in, I can get this stuff down. Anyway, so there's our discussion board. Here's where you're going to find what I'm doing right now. Here's the PowerPoint we're about to go over. But let's talk about CK12. So let's head on over. So if we head on over to CK12, I love that people are getting a lot of work done on it. Keep it coming. Remember our last lecture, which is next week, will be the last assignment you have. And you'll, trust me, I'll be fine with this assignment. And then the following week, the May 6th, absolute cutoff. That's when I have to turn in grades. So just be aware. Hopping into our assignments now. Here we go. Here's wins. Why is it still thinking? There we go. All right, so if we get into wins, look at that. Same as before, just 3 sections, no quiz. All I want you to do is complete the adaptive practice. If you complete the adaptive practice, you're good. As long as you've completed it, I don't care if you got a 60%. I don't care if you got, a 56%. Just get it done. Just do it. Just do the work, complete it. You'll get the grade you want. Or you get a passing grade. I'll tell you that. But anyway, so as always with the CK12 units, adaptive practice is the main thing, but you have these articles you can read, and they're really cool. We start talking about circulation of air in the atmosphere, great study aids to use in the adaptive practice, videos that will sort of explain some of those questions and real-world examples, because that's what we're all about. And then you have just circulation, global wind belts, and local winds. And we're going to be talking about all of those in the lecture, so let's not put it off any further, and let's hop on into it. So remember, when you're doing your CK12 stuff, if you want to have these PowerPoints up, it doesn't have to be the lecture one. It could just be the regular PowerPoint. It's always just a good idea because it, kind of, you have like your notes in front of you. Like if you're writing a paper, of course you're going to have your notes in front of you. Just something to have there. So, I could turn on a laser pointer with this on. That's pretty awesome. But anyway, you know what? Hold on. I think I kind of blew it. Maybe I didn't. Hold on. Let's see. Turn on laser pointer. Ooh, this is going to be fun. Ooh, this is going to be a lot of fun. Okay, cool. So here we go. Look at this. All right. This lecture is going to be like 4 hours long. Global and local winds. So we want to start by, let me move some of this stuff, talking about what is wind. We experience it every single day, but what is it? So all it is just the movement of air caused by differences in air pressure. It's like any other fluid. It flows from areas of high pressure to areas of low pressure. If you had, it's going to sound weird, but if you just had like a bag of air, like if you took a little Ziploc bag, blew some air in it, sealed it up to where it wasn't like, about ready to burst. And if you apply pressure to one side, the air in that bag is going to move to the other. And that's a wind. That's a movement of air because of difference in air pressure. And so the greater the difference in air pressure, the faster the wind moves. So if you step outside and it's a gentle breeze, there's not like some huge difference in air pressure from the air masses around you. But if like you go outside on like a Santa Ana winds day and there's like, trash cans just, being blown down the street, there's like little kids flying through the air, then you're probably talking about some pretty significant pressure differences. And that's what's going on. That air, it's rushing in the direction of lower pressure. It's coming from the higher pressure towards the lower pressure. And zip around with that just because I like it a lot. And let's keep going along. So with air pressure. So differences in air pressure are caused by the uneven heating of the Earth. That's the biggest thing. The Earth is not straight up and down. The Earth is tilted on its axis, 23.5 degrees. That 23.5 degrees is why we have seasons, and it's why we have wind. So because of that tilt, and I think I have now this isn't the best, substitute because it's the moon, technically. And I'm that guy who has a little globe of the moon. But anyway, so we're kind of tilted just like how this moon structure here is tilted. And so sun rays that are coming in, they will hit this polar regions almost at an angle to where if it's coming in straight, like at the equators, it comes in pretty directly. And so what happens there is that causes an uneven heating of the Earth to where the equators and the subtropical regions, they get much hotter than the polar regions, which makes sense. We know that. But because of that, when anything heats up, like, the molecules sort of speed up, gases expand, so you have motion. So that uneven heating causes the motion. And these uneven heating events, I shouldn't say events because it's happening all the time, but the uneven heating produces pressure belts. We're going to look at that in a second. which usually occur every 30 degrees in latitude. Why that's the case, I honestly cannot tell you right now. I'm sure I can look it up. But every like 30 degrees in latitude, we have these different sort of pressure belts or cells, as they're sometimes called. So let's take a look at them. So here we go. This is really cool. It's one of my favorite graphics that I use when I'm teaching. But these are, obviously this is our planet. And if we start here at the, whatchamacallit, at the equator, that's what it's called. But anyway, so if we start here where it gets most direct sunlight, so it heats up a ton, you have that air that gets heated and it raises up and it sort of pushes out, and then it gets colder and it sinks and it falls back down to Earth where it's closer to the surface. So it heats up once again as it moves this way and it goes up, and that whole cycle repeats. Kind of like when we were talking about convection cycles within the molten Earth. Within the like mantle material. Same thing going on here. It's just the movement of fluid based off of convection and the uneven heating of the planet. And so you can see just about every 30 degrees here. So we're at 0 degrees here, and that's where we usually have air lifting, and then it falls around 30 degrees north and south. It will once again. So this air that's in here will move this way, and then it will, for reasons that we're going to discuss, it will rise up through the atmosphere, and we sort of have this cell going over and over and over again. In each of these little areas, we're not going to talk about all of them, but we'll talk about like the doldrums. We'll talk about like the horse latitudes and all the names like the easterlies. We're not going to worry too much about like Hadley cells and whatnot, just because we don't have the time, and it's a lot easier to talk about these in class. So, as warm air rises at the equator and moves towards the poles, it cools. As it cools, some of the air sinks around 30 degrees north and south of the equator. We're about at 34 degrees, here in the Los Angeles area. So we're not too far away from where it starts to, sink as it cools, but we're very close to it, which is why we have a very sort of nice, moderate temperature, mostly. There we go. And so if I just sort of show you that, you can see everywhere like that the air is rising up. So where the air rises up is where it's being heated, and it could be like surface processes, it could be the sun, and we'll go forward from there. So at the poles, the cold air sinks. So once that air gets to the poles, well, now it becomes cold. And when anything becomes cold, like the molecules come together and it becomes more dense, and then it will sink. And as it sinks, it starts to move away on the Earth. And as we're turning here, you'll learn from the Coriolis effect, we start to develop these polar easterlies. So around 60 degrees north and south, the air begins to, let me move this out of the way, hopefully it's not blocking you, but the air begins to heat up and rise. And so if I just hop back to that same visual, so around 60 degrees, it'll start to heat up and rise once again. And so as it's been traveling through, sometimes it's heated by this warmer ocean right here, and then it'll rise on up, and the whole process will start again. And so the global winds, so the combination of the pressure belts that we just saw there, and the Coriolis effect from the video you saw with the discussion board, these cause the global winds. When we say global winds, these are global wind patterns that always exist. Local winds are different, because local winds could be affected, by simple things like buildings. They could be affected by, just overall the geography of the area more so than if we're thinking about the planet as a whole. So those pressure belts that we saw that create the global winds. So the global winds that we have are called the polar easterlies, the prevailing westerlies, and the trade winds. And we'll get into each of these and why they're called what they're called. So here's sort of a breakdown of how they are. This isn't the best, visual, but it'll do. And so the polar easterlies up here, so they're this, up top and down below, they're coming from the poles, and you can see that they're sort of named from the direction they're coming from, not the direction they're going to. So the easterlies are moving from the east to the west. And then when we get to the westerlies, which is around the area that we have, they are moving from the west to the east. That's something that's kind of like hard to get down sometimes, is the direction of the wind. And then we also have what are called the trade winds. These are called the trade winds because these were the winds that they wanted to sort of get into when they were sailing back in the days, so they could trade global goods. And then we have this fun spot called the doldrums, where these sort of areas meet, where there's usually no wind at all. So if you ever hear like, "Oh, I'm caught in the doldrums," it means like you don't have much, motivation. You're not making much progress, and so that's one of the reasons that they're called that. So the polar easterlies, we'll start there. So these are wind belts that extend from the poles to about 60 degrees latitude, like you can hop back and see on there. So we go from the poles to about 60 degrees. And these are formed when that cold sinking air moves, that's coming from the poles, creating the cold temperatures, begins to sink. So that cold air sinks down, and as the planet spins, it kind of tilts it a little bit. So these winds come from the east, and they are very cold, and they make their way to lower latitudes. And you can see them here. So they're kind of up top, and as this air gets cold up here and it sinks down, it starts to sink, but as the planet spins, it sort of pushes it off, and we create this polar easterly wind. And then we have what's called the prevailing westerlies. So the prevailing westerlies are the wind belts found between 30 degrees and 60 degrees latitude, and they flow towards the poles from the west to the east, carrying the moist air over the United States. And so this is why the United States has such great farmland. You kind of have this moist air that's not too hot, not too cold, just that perfect combination for creating great farmland, great temperatures, very habitable places. And so we can see them here. So this is where we have, once again, they're called the westerlies because they're coming from the west. And as that air moves due to the Coriolis effect, it goes towards the east. And so if we look back at this, so they're flowing towards the poles, carrying the air. And so they're taking the air that's rising up right about here and carrying it towards the poles. But as it's sort of carrying it that way, the rotation of the Earth sort of curves it off, and we have the prevailing westerlies. And then our trade winds, those go from 30 degrees just about to the equator. Not quite to the equator because that's where our doldrums are, but they're called the trade winds because they're used from early sailors. They would use these winds to make their way to trade goods. And it makes sense. I mean, you got like mainland Europe over here, and you had Africa down in here. You had like the Indies, and you had India over here. And so these would be the areas that you would want to sort of get into and make sure you can trade towards all these heavy populated places. And so what you have here is this air traveling towards the equator, and with the rotation of the Earth, it's sort of spinning off to the left here. So coming from the east, spinning to the west. We don't call them the easterlies because we already have them up here, and it just made more sense to call these the trade winds. And then we have the doldrums. The doldrums are located along the equator where no wind blows because the warm air rising up creates an area of low pressure. So it's usually very clear but very hot, and you have this air that's rising up and pushing its way out at the equator, and it creates this huge area of low pressure. So when there's like no pressure, you're not going to have like a flow, really. You won't really have the wind, which is all well and fine unless you're a sailor trying to make your way somewhere and you get caught in the doldrums. That is a no-go there. I just realized how I'm doing this. I thought I was connected to my AirPods. I'm not connected to my AirPods. I'm going to take those out because now I just feel like a fool. Anyway, then we also have what's called the horse latitudes. So these occur at about 30 degrees north and 30 degrees south of the equator, where the trade winds are very weak. And so this is where you also see like most deserts on Earth are in this latitude because the air is really dry. So as it sort of sinks and heats up, it becomes very dry, and the winds become very weak, and we have deserts in these areas. Now, once again, if you have weak winds, you're not going to be able to sail as you would like to. So the reason these are called the horse latitudes is one of the things that they would do is they were, on their ships on their way coming over, and now there's no more wind. We got to make your ship a little bit lighter so it'll go. So over the side went the horsies. Terribly sad. Terribly sad. Let's move on from this before we start crying. We got to pour one out for the horsies later on. All right. We also have cool things like the jet stream. The jet stream is a really neat narrow belt of high-speed wind that blows in the upper troposphere, lower stratosphere. We're not going to get into the layers of the atmosphere just because we're running out of time. in the class, but this separates warm air from cold air. So you can kind of see if you have like a big old cold air mass and then a warm air mass, man, saying air mass really fast is a dangerous proposition because you can mess that up quick. But the cold air mass, this area in between is just sort of super high area of wind. So it goes very fast through here, and oftentimes airplanes will try to get into the jet stream because if they're going this way, if they get into the jet stream, it's almost like getting like a little extra boost. So like you're improving the gas mileage of the plane, but also you get to your destination a little bit quicker. One time when I was coming back to LA, and I had been in London, I came back to LA and we hit the jet stream, and we landed something like 45 minutes before we were supposed to land because we were able to like ride that jet stream and go like something like 600 something miles an hour. It was wild. Like you can't tell, but when like the pilot comes on, like we're in the jet stream, we're going 600 miles an hour. You're like, oh yeah, this is awesome. And then it was great because I got to land at LAX and then spend 6 hours trying to get out of there. So now we'll talk a little bit about local winds. I like local winds. They're generally that move short distances, and they can go in any direction. They don't have like a traditional, they always go from the west to the east or from the east to the west. These are just kind of winds that blow in just any direction that they choose. Wherever the air is able to flow, it's going to flow. And these are caused by geographic features that produce temperature differences. That's one of the big things is the temperature differences. So one of the best examples of this are what are called land and sea breezes. So the sea breezes are high pressure areas that are sort of created over the ocean during the day and low pressure over land due to uneven heating. And the reason for this is some of the amazing properties of water. And so what happens there is so the sun's just beating down on the ocean, right? And water has a very high heat capacity. It could take in a lot of heat. That's why it takes so long for water to boil. And so it takes in all this heat. And then what happens there is the land mass that can't take in the heat, the air from the land mass rises up. And then you have this motion of, once again, different pressures. So the high pressure is created over the ocean. And then as the air heats up and rises over the land, it creates low pressure. So that high pressure moves in and that low pressure moves out. So you have that breeze coming in from the ocean. And so when you're down, next time you're down at the beach, you're like, this is the sea breeze because it's during the day. And you can see out there, that ocean is taking in quite a bit of heat. It's caused a lot of high pressure. Over here on the land, we got low pressure. So that's why we're feeling that wind coming in, everybody. And then you'll look around and be like, oh my goodness, I have no friends. Like I wanted to talk about science at the beach. Anyway, so the air moves from the ocean to the land, creating that sea breeze. And here it is. So we have this high pressure area. Not only can the heat capacity of water not only does water have a very high heat capacity, but also as the area over here, as your warm air is rising up and making its way this way and cooling down, it'll subside. And then you have the high pressure over here that goes back towards the low pressure and over and over and over again. And so this is a really good graphic to use when you're answering your questions. Okay, so land breezes. So land breezes, there is a low pressure. Hold on one second. I got to see if I can do something real quick. I got to see if I can pause. All right, I'm back in with you. So that was the first time I've ever paused a Screencastify and then started it up again. Trying something before I've just done one straight shot. So that's why they always seem so professional. I don't mess up at all. But let's hop on back out here to the expanded version. We're almost at the end, I promise. So with the land breezes, so we have low pressure occurring over the ocean during the nighttime. So during the nighttime, it's a little bit different. The ocean sort of releases its heat that it sort of accumulated during the day, and that creates low pressure over the ocean, which the air will rise up, and then the high pressure that's over the land comes in and takes its place. Sounds just like that too. If you're ever down at the beach at night and you hear a you're like, oh, that's what it was. Joking. I have to get these last few jokes in. I only got 2 more lectures. But anyway, so this causes the wind to move from the land towards the ocean, creating what's called a land breeze. And we can see here, it's just kind of the flip-flop of the other one. So we have this, the ocean, you will, the sea, whatever you want to call it, Just it's been pounded by the sun the whole day. It's got a ton of heat that's being held, and then lo and behold, the nighttime comes and the air gets colder, but the ocean is allowed now to release its heat, creating this low pressure area around it. It rises up, it spreads out, and then this high pressure that was over the land, it just runs on in here and it just takes that spot, and then it gets heated up, and then it'll rise, and it comes over, and this just goes on and on and on and on. That's why I feel like a nice little consistent cool breeze down at the ocean. How lovely. Spend some time this week. Be like, I got to do some school research. I got to go down to the beach for the day and experience the sea breeze and the land breeze. So we got to grab a cooler. We got to head down there, and I got to do some homework by just experience the breezes. You don't need my excuses to go to the beach. So if we just want to look over a few things, like you'll see in the CK12 unit, what causes winds? Winds are caused by the uneven heating of the Earth's surface, which causes pressure differences. Anytime there's a pressure difference, there's going to be movement. That's just the way the world works. Number 2, what are the 3 types of global winds? Oh, if you saw this on the adaptive practice, you're like, oh my goodness, I have no idea. You want to have the screen up, because then you're like, oh yeah, it's polar easterlies up top and down below, because they flow from the east. There's the westerlies that are in those like middle latitudes, and they come from the west to the east. And then we have the trade winds, which are, sort of sandwiching in between that equator. Question 3, what is the difference between a land breeze and a sea breeze? Well, the difference is where the pressure systems form. For a land breeze, hop back if you want to see it here, because right there. So for the land breeze, oops, a little too far, the pressure system, the low pressure is over the water as opposed to over the land. If we hop back, for the sea breeze, the high pressure is over the water, low pressure is on land. So if we go there, what is the difference between the two? A sea breeze occurs during the day when the land is warmer than the water, and then the land breeze occurs at night when the water is warmer than the land. Because the land doesn't take in heat very well. It just sort of bounces it back up. That's why if it's 100 degrees and you're like walking like on the asphalt or something, you can just feel like radiating back to you. Water absorbs that heat. And so during the day, when there's like low pressure out there, but there's high pressure over land, that's why we get that sort of circulation of air. Oops. Oh, and there we go. Cool. I came to the end of it. So yeah, and we'll go into this one a little bit more because I got a little bit of extra time. But so with our land breeze, we got that low pressure. This has been heated up all day. That air is warm and rises. This air over land, it hasn't been holding in the heat, so it just gets cold and it just sinks. And then it comes back out here, and then that whole cycle starts again. About hop over to this one, we got high pressure system here. This high pressure system is caused by, you have this area over the land. So this is just the ocean's just pulling in all the heat. So since it's pulling in the heat, you don't really have that low pressure of the rising air that we see in the other breeze. But now the low pressure is over the land. So since it's over the land, it will rise up. And then since you have low pressure and rising air here, the high pressure will come from this side, from the ocean or from the sea, to rush into that area and create a sea breeze. So there you go. There's your global wind belts. There's a little bit of local wind patterns and some of the things that we experience. I love doing the lectures for you. Hopefully, if you watch them, if you don't, no worries. I still enjoy doing them. Let me know if you need anything, and I will see you in the eye of the hurricane next week. Signing off. This is a really bad attempt at a joke. I'm sorry. Goodbye.